So let's start with the most fundamental aspect of motion, that is distance versus displacement. Now, distance actually, please recall yourself what is distance, what is displacement. Have an idea before I tell. Okay, so distance is the actual path while the displacement is the shortest path. So I do have this actually. Let me show this. Oh yeah, this is character. Okay, I'll show it in the next. And the SI unit for both is meters. So let's look at the definition. Distance is the length of the path followed by a particle. Displacement of a particle is defined as its change in position in some time interval. Displacement is the length of the straight line which joins the starting point and the ending point. Now, some of the characteristics of displacement. So let's have a look. Let's go one by one. Let me reduce all of this. Again, it's displacement, not distance. So displacement can be positive, negative, or zero. Why? Because the displacement is a vector quantity. And so we can talk about left, right, up, down, so on and so forth. So because of that property, displacement can be positive, negative, or zero. While distance is a scalar quantity, it's all about magnitude. So there we just have either zero or positive. If say I can consider that something to the right is positive, something to the left is negative. It's left to you guys. How do you want to describe it? Yes, you can describe left to be positive and right to be negative. Displacement is always a unique path. Displacement is not dependent on the choice of path. For example, if an ant moves in the first path, in the upper path, while the same ant in the second scenario, it takes the bottom path. Because the starting point and the ending point is the same, the displacement will be this straight line which connects the starting point and the ending point. That's it. That's your displacement. So it's not dependent on the choice of the path. It's always a unique path. If the starting point and the ending point is same, it is fixed. There is only one way that the displacement can be considered. But the distance can be infinite possibilities. There are infinite possibilities and can go in many ways and reach the destination. Yes, displacement is always either lesser than or equal to the actual distance. If this blue line represents the distance object traveled, right? So the displacement will be the green line. That's it. Okay. So we have displacement is not dependent on the choice of origin. Okay, I showed you that as well. I do have one more video. Yeah. Oh, that's displacement is not dependent on the choice of. Okay. Yeah, this is a different point. Sorry. So let me explain this. Again, it's a continuation. So what we're looking at is two number line. Please see the origin. They have been shifted. Now, if I happen to consider an object moving from same point to the same point. Okay. So can you see that? Forget about the numbers. It just moved. Can you see that the length is same? If I happen to consider this, if you ignore the number, you can see that it started with the same point. It has stopped at the same point. You guys agree? Now, the displacement in this case is a set of straight line. So are the straight lines same? The lengths are same? It is, right? I should not be showing this. Again, I just taught 6th graders, so I might feel a bit slow, but I'll pick up the pace. Can you see the lengths are same? Do you guys agree? But in the first case, it is moving from 1 to 4, the coordinate 1 to 4. In the second case, it's moving from 5 to 8. But the difference between both the cases is 3. So does it make sense for us to worry about the origin? Does it make sense? Yes or no? No, right? So it is independent of where the origin is. Again, all this will add up. It's like learning small tricks. How to use it is left to your skills. One connecting question. When is distance equal to displacement? It's a very famous question for a ninth grader. When is distance and displacement the same? Are there scenarios wherein the distance and displacement is same? If I happen to consider an object, if I happen to make it say move something like this. Okay, say it's starting from here, or let me start from this point. It went like this and went like this. Okay, so basically the journey was so, roughly it's so, while the displacement will be just this, right? So this is the distance aspect, while this is the displacement. Okay, now the question is, when will the displacement and distance be same? I hope you guys remember, if the starting point is over here, that is the start. This is the end. What we have here is, and the path the object takes is just a straight line. And it stops over here. In this case, what is the distance and what is the displacement? It is same distance is same as your displacement in this case. So if an object moves along a straight line in the same direction, then the distance and the displacement will be same. So distance and displacement will be same only if the object moves in a straight line and in the same, in same straight line and in the same direction. Okay, if an object goes and comes back, the distance will keep increasing. Don't worry, I'll show you that. While the displacement can be zero as well. Okay, let me show this actually. We have a turtle, and as you can see, it's slowing down. That is a snapshot. So every second snapshot, you can consider that. And now it is slowed down completely, and what is happening? It's going back. Okay, so it went forward and it's going back. So let's see what happens with the distance and displacement. So that is this top to your distance and displacement. Can you see that? Can you observe? Actually, you should be observing. Look at the x and y axis of both the distance and displacement. What's happening? Is the distance value, is it increasing throughout? Has it dropped like in displacement? As the displacement crossed the negative, as it crossed to negative value, observe. Right? So both started off with 0. Displacement increased and then it dropped, while the distance it kept on increasing. Alright, even though it went reverse, distance does not care the direction aspect, while the displacement does. So it went, with respect to the origin, it went back. Where it started with, it went back. It went a bit forward and then it went back. So displacement can be 0, positive and negative, while the distance can be only 0 and positive. Right, I think I've covered all the points. So that is your distance and displacement. So pause, and whatever you feel like copying, you can. Characteristics, let me show the points again. Displacement can be positive, negative, or 0. This is to do with the next point, that is displacement is not dependent on the choice of origin. Okay, so that's that. So you can draw this itself actually. And yeah, for that point. Again, guys, all this will add up. In time, it will add up. Okay. And when is this distance is equal to displacement? It's a simple question.